Now let's see some properties of this pole zero plot. So an important thing to note is there should be no poles inside the ROC. Why is that true? Because ROC itself says that it is a region of convergence, which means if you evaluate the Laplace transform x of s at some point A and you say that A belongs to ROC, then it should be finite. It should not be infinite at that point. Poles means that the value is infinity at that point. So the poles should not be part of the ROC. If they are part of the ROC, then ROC definition itself is contradicted. So the first thing that we can notice, there should be no poles inside the ROC. There can be zeros inside the ROC because the value x of s equal to 0 makes sense. It's still finite. So there can be zeros inside the ROC, but there should not be any poles inside the ROC. So which means poles can be on the boundary of ROC. So poles can bound ROC, but they cannot be inside the ROC. So for a right-sided signal, where will the poles be located? Because for a right-sided signal, we always said that, so for a right-sided bounded signal, we already said that the ROC is on the right of the S-plane, okay. So if it has multiple poles, let us say I have a right-sided signal whose poles are like this. Now, where would the ROC exist for this signal? So the point that we are making here is the ROC is going to be to the right of the rightmost pole. So this is the rightmost pole. So all the values here will be present in the ROC. Why is this true? Now what are we saying? So we are saying x of s is some numerator polynomial, some polynomial here, n of s, and the denominator polynomial contains some roots. Now let's order the real value of the roots of the denominator. So let us say there is some order like this, something, and let us say the maximum is some beta max. So this is the largest value of the roots. Now any sigma which is greater than the real value of beta max, if you plug in that s with that particular sigma here, this polynomial is not going to be 0, right? Because we found out, we listed all the roots and we said that for all these anyway it is not going to evaluate to 0, which means this cannot be infinity, and because it cannot be infinity, we can say that it is present in the ROC. What happens to the numerator polynomial? It does not matter. The numerator polynomial anyway cannot go to infinity. The numerator polynomial at best can go to 0, and it does not matter. It can be 0, so what? So it's still defined, it's finite, so that's not a problem. So we say that for a right-sided signal, the ROC is to the right of the rightmost pole. You pick the rightmost pole and everything beyond that is part of the ROC. Okay. So this is true for the right-sided signal. So if somebody gives you an ROC which looks like this, then immediately by looking at it, you can say the signal has to be a right-sided signal. If I pick a point, let's say somewhere arbitrarily here, and ask if this belongs to the ROC, so let us assume that it belongs to the ROC. If it belongs to the ROC, then we already saw that for a right-sided signal, if a point belongs to the ROC, then anything on the right of that particular point will also be in the ROC. But in this case, to the right of it, there are multiple poles, right? So this cannot be inside the ROC. Hence, anything on this side, that is the left of the rightmost pole, cannot be part of ROC, simply because for right-sided signals, the ROC has to be right-sided. So for a right-sided signal, the ROC is always to the right of the rightmost pole. Similarly, for a left-sided signal, the ROC is always to the left of the leftmost pole. So in case this pole zero plot was corresponding to a left-sided signal, then the ROC would have looked like this. Okay. So if it is two-sided, let us say the signal was two-sided, then the ROC is a strip between the rightmost and the leftmost pole. So in this case, the ROC could be something like this, or it could be something like this. Could be one of these things. Okay, that depends upon the signal. So as an example, we saw that e power minus at u of t, we saw that it is 1 by s plus a, right? And we also saw the ROCs on the right side. Now, where is the pole for this? The pole here is at minus a, and clearly the right of the rightmost pole is the ROC here. And when it is left-sided, left of the leftmost pole is the ROC here.